ah. I made too many mistakes. They changed something. It feels a little bit weirder today. What is this whole finding your wrist? This is ugly. I don't like it. Okay, I'll take it. Good morning. To no one in particular. I know I'm really early today. Which is fine. Let's get started. This rules. Recursion is also related to fractals, images which contain multiple smaller copies of themselves. The banner at the top of this page is one example. The next exercise creates a simple, repeating pattern using recursion. Unscramble the lines to create a program that produces a recursive, ruler-like design. For example, when n equals 3, the program should output the following design. 1, 2, 1, 3, 1, 2, 1. Okay. I want to see the banner. Oh, this back here is a fractal. Cute. So let's see. Definitely to define a ruler first. We need a base case. If n is equal to 1. um else hmm hum. So if n is equal to 3, we want to print n times this. Hmm. This is not correct at all. Hmm. Hum 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 hum. Oh, else? Else? N minus 1? No, ruler n minus 1. Okay. So n is 3. Ruler of 2 would subtract. Ruler of 2 would check, is n equal to 1? No. Meow, 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 meow. I hate this, I hate this, I hate this. Oh no, I hate this so much. Oh god, I hate it so much. Um? Ha 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 ha. What if you put 1? That does not work. That's 0. I don't get it. I'm really sad. I don't get it. In the a recursive ruler-like design that does 1, 2, 1, 3, 1, 2, 1. Ruler n. This does not go here. Ruler n minus 1 is too indented. It doesn't go there. If 3 is equal to 1, print this, else ruler of n minus 1. If it's 2, print this. It's not 2. Ruler n minus 1. If it's 1, print. I'm so sad. I'm so sad. I'm so sad. I'm really sad. I don't get it. I don't get it. I don't get it at all. I'm also sad for unrelated reasons, but I'm sad for this as well. I just wanted one break. Can't I get one break? Please, for the love of God, can I get one break? Let's do this first. Okay. So that prints 3. If we do ruler and -1, we get 1, 2, 3. Hmm. Ha 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 ha. Let's think. What is that? What it's doing is, if it's 1, we print. If it's not 1, we do recursion. So it goes from 3, wait, n equals 3. Oh, okay, so it does the printing after. N equals 3. Second ruler. N equals 2. La 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 la. Where n equals 2 and doesn't equal 1, so the third ruler, n equals 1. And in that one, wait, let me double check this. So n equals 3. If n equals 1, print. Otherwise, do ruler first. Do meow meow meow. Call ruler 2. Second ruler, n doesn't equal 1, so we're gonna call ruler on 1. The third ruler on 1 is gonna print but now we still have to go all the way back up the stack. So we go back to the second ruler, which called ruler 2. I think I'm writing this really weirdly. I think I should write this more clearly. Ha 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 ha. What do I call these steps? Step 1, call. That's not true. Step 1. That is step 2. Meow 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 meow. Call ruler 3. Call ruler 2 recursively. I don't like this. I don't like how I'm writing this. Does this make sense? Does this make sense? First we call ruler 3, and that calls ruler 2. And then that calls ruler 1, and then ruler 1 prints one of those. And then we want to, what does calling ruler 2 do? Ruler 2 prints meow 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 meow. It doesn't print meow meow. And then 6 prints 1 2 3. So what we want to do instead, call ruler 3, call ruler 2, call ruler 1. What would happen if we called another ruler n-1 here? What would happen? In this case, we would get to this line, and instead of printing 2, we would do 1 again. I think I have to put it here. But this just doesn't look right to me. Call ruler stray. Ruler. Wow, this doesn't look right to me. This is a trick. Are they trying to trick me? Call ruler 3. That calls ruler 2. That calls ruler 1. A ruler 1 prints this. A ruler 2 prints this. A ruler 3 just print this. I don't get it. 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 I don't understand it. This is really bad. This is really, really, really bad. Why does it do this? Let me think slowly. Call ruler 3. Ruler 3 then goes to ruler n-1, which is ruler 2. Ruler 2 does if n is 1, print 1. Wait, no. Ruler 2 skips that. It goes and calls ruler 1. Ruler 1 prints. And then we go back to ruler 2? I guess we do. We go back to the instructions at ruler 2. Oh, I see it now. So what ruler 2 does is it prints 2 and then it calls ruler 1 again. I see it now. I see it now. Then ruler 1 prints one of these. And ruler 3 is still open. So ruler 3 finally gets to print. No, I lied. Did I lie? No. Ruler 3. I think I should write more details. Call ruler 3 to call ruler 2. Call ruler 2 to call ruler 1. Call ruler 1 to print one of these. Continue ruler 2. So print 2 of these. Continue ruler 2. Call ruler 1. Call ruler 1. Print one of these. And then we have to go back to continue ruler 3. So where we left off, ruler 3 n-1, that ran already. So, but we still have to do the print. So print 3 rulers. And then continue ruler 3. which calls ruler to call ruler to, and I'm not being consistent here. I think we would take out the 2. We take it out. Take it out. We take it out. Calls ruler 2. And then what is calling ruler 2 do? Calling ruler 2. Call. Wait. Call ruler 2. My brain hurts. Meow, 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 meow. Call ruler 2. Meow, meow, meow. Meow, 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 meow. To call ruler 1 again. And then I didn't think it was gonna be so many steps. I didn't think it was gonna be so many steps. Shift. Oops, I didn't mean to do that. 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 Yeah. Meow, meow, meow. Calling ruler 1. Call ruler 1 to print. It looks like I'm calling twice, but I don't mean to call it twice. I'm just saying, like, it's like it's like assembly with the the jump. With the go to, and then like the instruction itself, something like that. Just pretend. Okay, and then what happens after we print that? After we print 1, we have to finish up ruler 2. Continue ruler 2. And that does the printing, so that prints another 1 with 2. 1, 2, 1, 3, 1, 2. And then that continues again. Continue ruler 2. Call ruler 1. And that call ruler 1 prints another 1. But then 1, 2, 1, 3, 1, 2, 1, 3. We have to continue ruler 3. Ha ha ha. Ha ha ha. Continue ruler 3. Which continue ruler 3. Which does what? Print. Is it print or something? Wait. Am I lying? Calls this. But we only get 1, 3. 1, 2, 1, 3, 1, 2, 1. Let me double check something here. Yeah, there was never a call to 3 again. The call to 3 which results in calling ruler 2. Call ruler 2 results in calling ruler 1. Call ruler 1, which results in printing. Continue ruler 2, which results in printing. Continue ruler 2 again, which calls ruler 1 one more time. Call ruler 1, which prints. Call ruler 3, or continue ruler 3, which is the print line. We'll then continue ruler 3 by calling ruler 2 again. They call ruler 2, which calls ruler 1, and then calling ruler 1, which prints, and then continue ruler 2, which prints, continue ruler 2 again, which calls ruler 1 one more time, and then we print. And that's the whole thing. Those are all of the steps, I'm pretty sure. I still don't understand recursion. After all of this work, I still don't think I understand recursion. Whatever. It's fine. Whatever. Oops. Quit this. In this lesson, we give more detail about how Python stores lists. Copying and comparing lists can have unexpected consequences. We will explain how Python works internally so that you can understand and avoid these mistakes. The general issue is that several different variables can point to or refer to the same list. Towards the end of this lesson, we describe the is operator, which tells whether or not two variables really point to the same exact list. Oh yeah, because there's like equivalency in value, and then there's the same object or referring to the same object. Okay, let's see. We want a code fragment to convert a list of lengths in inches called old size to a list of the same lengths in centimeters called new size. One way we might try to do this is to use the line new size equals old size to make a copy, then go through and change all the values. Okay, but I don't remember which one makes shallow and deep copies. I remember that exists, but I didn't learn it very well. Okay, let's see. Old size equals letter 8.511. Size of paper in inches. New size equals old size. Make a copy, question mark. New size 1 index 1 times 2.54 convert to centimeters. Now let's see if this actually works. If you print new size, then it gives letter 2159, 2794 as expected. What's important to notice is that when we print old size, the value of old size has changed. We illustrate below. So we have the paper, and then we have what we're doing here is in the first line, we're creating a list object and naming it old size, or in other words, attaching a label or creating a label, creating a name that points to this list object. And then in the next line, we're creating a new name that is pointing to the same exact object that old size is pointing to. Make a copy, question mark. So when we make changes to the new size and we print it, we see that both of them get changed. Yeah. We'll now give a detailed explanation of exactly what happened using diagrams. The main problem is that new size equals old size didn't really copy the whole list, it just copied a reference arrow to the same list. Click on the slide titles to change tabs. First we have memory. Oh, I'm excited about this. I'm excited. We'll use a table to represent variables and values in Python's memory. For example, after running the code, city equals Moose Factory, population equals 2458, employer equals city, this table with the black border shows what Python's memory looks like. So you have a variable name, city, population, employer, and then you have value. Moose Factory, 2458, Moose Factory. The first variable's name is city and its value is the string, Moose Factory. The second variable's name is population and its value is the integer 2458. The third variable's name is employer and its value is the string Moose Factory. Next, we show what a list looks like in memory. For example, take the code fragment mylist equals Moose Factory 2458. This will just create one variable named mylist. A list is created and the value of mylist is set equal to point or refer to that list. We represent the list using a box, and the values of the list entries are shown inside the box next to their corresponding indices. The list is shown in blue. So we looked at this kind of thing before, but yeah. My list is a list reference to this list that contains an element Moose Factory at index 0 and then 2458 at 1. The arrow shows that my list refers to the new list. The element at index 0, I just said this. Oh my gosh, I promise I didn't pre-read. So this is a string Moose Factory and an element at index 1 is integer 2458. For example, if you print my list 1, then Python will output 2458. Replacing a list value. Now we add one more line to the previous example just for illustrative purposes. A baby is born, so we run the code fragment mylist equals the list, and then mylist1 equals mylist1 plus 1. Python calculates 2458 plus 1, which equals 2459, and this replaces the value at index 1 of the list. After the update, we have the diagram shown below. The crossed out 2458 is shown to emphasize the change. Now we go back to the main example. The first line was old size equals letter 8.511. And so Python's memory looks like the diagram below. After the line is executed, we created a list of length 3 with index 0, 1, 2, and those values. In our program, the second line is new size equals old size, and the most important point in the lesson is here. It does not, or equals, does not duplicate the list. Instead, it creates a new reference to the same list. This is illustrated by two different arrows pointing to the exact same box. As the diagram shows, we have two variables, which both refer to the same list. Next, when the program reaches the line, new size, index 1, and then you change the size, Python looks at new size, looks up the value of its index at 1, which is 8.5, and multiplies it by 2.54, and then replaces the value as shown. However, since old size refers to the same list, a side effect is that we also affected what old size refers to. Again, the crossed out 8.5 is shown to emphasize the change. The next line is similar, which affects the other value in the list. After this line executes, Python memory looks like the diagram shown below. Now when we print new size or old size, Python outputs this new thing. Okay, yeah. To just see pictures without commentary, run the same code in a visualizer. Actually, every value in Python is an object living in a specific chunk of memory. And every variable is just a reference or pointer or arrow. Example, in the first slide, memory only really contains one moose factory with 2 arrows to it. Because number and string objects are immutable, we draw them without arrows in these lessons, but behind the scenes, Python treats all data uniformly. Read more here. Whoa, what is this page? Oh, what is this page? Oh, is this part of a book? Wait a minute. I don't want to buy it on Amazon. I don't want to buy the book on Amazon. Think base, think Python, think stats. Oh, this is think Python, not pink Python. Think Python, chapter 10. Oh, why does it say 11? What does it say? Oh, run. Anyway. Wait, is that binary? Just kidding. Am I kidding? A list is a sequence. I don't feel like reading all of this right now. Sorry. My throat hurts. Should I read the whole thing? It just seems so long. Oh god, oh god, oh god. We should read it. We should read it. A list is a sequence. Like a string, a list is a sequence of values. In a string, the values are characters. In a list, they can be any type. The values in a list are called elements or sometimes items. There are several ways to create a new list. The simplest is to enclose the elements in square brackets. The first example is a list of 4 integers. The second example is a list of 3 strings. So the first one was 10, 20, 30, 40, and then crunchy frog, ram, bladder, lark, vomit. The elements of a list don't have to be the same type. The following list contains a string, a float, an integer, and lo, another list, nested list. Spam 2.0, 5, 10, 20. A list within another list is nested. A list that contains no element is called an empty list. You can create one with empty brackets. As you might expect, you can assign list values to variables. Cheeses, cheddar, Edam, Gouda. Numbers, 17, 1, 2, 3. Empty. Print cheeses numbers empty. Okay, lists are mutable. The syntax for accessing the elements of a list is the same as for accessing the characters of a string, the bracket operator. The expression inside the bracket specifies the index. Remember that the indices start at 0. Print cheeses at 0 gives cheddar. Unlike strings, lists are mutable. When the bracket operator appears on the left side of an assignment, It identifies the element of the list that will be assigned. It's left and right again. Oh yeah, so numbers equals 17, 123. Points, makes a name called numbers pointing to a list with 17, 123. But then, if you do numbers bracket 1 equals 5, you change the 123 to the number 5, right? And then you print it. Okay, the 1th element of numbers, which used to be 123, is now 5. You could think of a list as a relationship between indices and elements. This relationship is called mapping. Each index maps to one of the elements. Figure 10.1 shows the state diagram for cheeses, numbers, and empty. So the cheeses points to a list that contains 3 indices or 3 elements. And then numbers has 2 elements, but it used to point to 123, and then we changed it to point to 5. And the empty points to a list that doesn't have anything in it. Lists are represented by boxes with the word list outside and the elements of the list inside. Cheeses refers to a list with 3 elements, index 0, 1, 2. Oops. Numbers contain 2 elements. Empty refers to a list with no elements. List indices work the same way as string indices. Any integer expression can be used as an index. If you try to read or write an element that does not exist, you get an index error. If an index has a negative value, it counts backward from the end of the list. The in operator also works on lists. We used this literally yesterday, and by we, I mean me. Adam in cheese is true. Brie in cheese is false. Traversing a list. The most common way to traverse the elements of a list is with a for loop. The syntax is the same as for strings. For cheese in cheeses, print cheese. This works well if you only need to read the elements of the list. But if you want to write or update the elements, you need the indices. A common way to do that is to combine functions range and len. For I in range, length of numbers at index I is equal to numbers at index I times 2. This loop traverses the list and updates each element. Len returns the number of elements in the list. A range returns a list of indices from 0 to n-1, where n is the length of the list. Each time through the loop, I gets the index of the next element. The assignment statement in the body uses I to read the old value of the element and to assign the new value. A for loop over an empty list never executes the body. For x in empty list, print this never happens. Although a list can contain another list, the nested list still counts as a single element. The length of this list is 4. List operations. I feel like this is a pretty good review. List operations. The plus operator concatenates lists. A equals 1, 2, 3, B equals 4, 5, 6, C equals A plus B, and you get a list that has all of those 1, 2, 3, 4, 5, 6. Similarly, the multiplication operator repeats a list a given number of times. 0 times 4, 0, 0, 0, 0. 1, 2, 3 times 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. The first example repeats 0 4 times. The second example repeats the list 1, 2, 3 3 times. I know, I just said that. List slices. The slice operator also works on lists. T equals A, B, C, D, E, F. T from 1 to 3. Wait, how does slicing work again? Does it start, stop? Or index 1 to index 3 uninclusive? We got BC. T up to 4. A, B, C, D. So that's index 0, 1, 2, 3. 3. Start at 3 and go to the end. Start at index 3. Go to the D, E, F. 0, 1, 2, 3. Yeah. If you omit the first index, the slice starts at the beginning. If you omit the second, the slice goes to the end. If you omit both, the slice is a copy of the whole list. Since lists are immutable, it's often useful to make a copy before performing operations that fold, spindle, or mutilate lists. A slice operator on the left side of an assignment can update multiple elements. So T1 to 3 equals XY. Did you get A, X, Y, D, E, F. Yeah, there we go. List methods. I was trying to do that. I was doing that in my head. I wasn't reading it. But they just were the same thing. Meow, 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 meow. Python provides methods that operate on lists. For example, append adds a new element to the end of a list. Append D to ABC, you get ABCD. Extend takes a list as an argument and appends all of its elements. ABC, ABC is T1, T2 is DE, T1 extend T2 is, it makes T1 equal to ABCDE. This example leaves T2 unmodified. Sort arranges the elements of a list from low to high. List methods are all void. They modify the list and return none. If you accidentally write T equals T sort, you will be disappointed with the result. Actually, I kind of want to try that. Let's try it. Why don't we? Why don't we try it? We take a list called meow and we put A, E, meow, C in it. And then, if we write meow equals, wait, let's do, no, yeah, meow equals meow sort. We don't get anything. Wait. None. We get none. Where's our list? It's gone. That's where it is. It's gone. Map filter. I really don't feel like reading all of this. Why was I reading this again? I thought I was gonna learn more about memory, but instead it's just a thing about lists. Is this the wrong? Did I link to the wrong one? What happens if I press this? Oh, this is the whole thing. Wait! Have I heard this book before? Have I heard of this book before? Have I heard of this book before? I released this book under the GNU free documentation license. I'm pretty sure. Wait, don't I have this book saved in here? Where are you? Where are you? Is this? Oh, this is different. No, Think Python: How to Think Like a Computer Scientist. How to Think Like a Computer Scientist Interactive Edition. Is this the same book? Who's this? I don't. Is this the same book? What the? What the? Oh wait. Oh wait. Oh wait. Is this just Alex? Okay. Anyway. I need a little break. I talked to the chat. Is anybody here? Did the stream end? No. Is it over? Did I lose frames? This went to the shadow realm. Oh. Teach C++. I can't teach anything. I don't even know how. I don't even know Python. Oh, did I DC? Bless. Good morning, JJ. Good morning, Pyre Blue. Morning, Nightmare. Morning, Rhythm. Morning, Rocketflare. Morning, Techie. Morning, Nader. Okay, have a good day at work. Morning, Blanket Child 710. Where have you been, buddy? How's life? Morning, Olive. Morning, the consultant. Morning, Crucial Flow Research. Good morning, Now. Good morning, Justy. Morning, User S85J. Good morning, Really Rife. Good morning, Barrett. And good morning, Peter. And also good morning, Burger. Good morning, McLovin. Good morning, Alex. Good morning, Kimino Niwa. Good morning, Zymore. Good morning, Starfarer. Long time no see. Actually, it's not been that long. It's been like, I don't know, a couple of days. Good morning, Zenzi. And you probably were here the other days, but I didn't see you because I didn't look at all the chat. Good morning, El Cholo. Good morning, Lundidus. Good morning, Yegin to Drago. Meow, meow, meow. And the other names I don't recognize. Good morning, Newton Breaker. Good morning, Phoenix. Good morning, Krang. What up? What up? What up? What up? We take attendance now. We're gonna do deep copying of a list in Python now. Chat has been full of new people asking the usual 3 questions and backseating. It happens every day. It never gets old. Okay, now I gotta lock in again. I'm locking in. That's right. Deep copying a list in Python. In the above example, we used equal to create a second pointer reference arrow to an existing list, which is usually called a shallow copy, although it is sometimes useful. For example, if we want several variables to refer to the same list, we save memory compared to making multiple copies. However, in our lesson, saving memory is not crucial. Here, it is not what we wanted. Instead, we wanted to create an entirely new copy of a list. How can this be done? We'll give 3 solutions. They are all pretty much equivalent, but each one will teach you a new fact about Python, so all 3 are worth reading. Method number 1, using the index with a colon. Copying with the brackets and a colon. Old list, first, second, third. New list is old list, but the whole thing. Create a copy. Old list, reverse. Print new list, print old list. And we should get two different things. So what do we got? First, second, third, and third, second, first. Oh, this is actually pretty funny. I wonder if that's... Wait a minute. I wonder if that's on purpose. Wait. Or do the words first, second, and third? No, that's just a coincidence. Anyway, because I thought the order is like a letter order of the first, like alphabetical kind of. Not alphabetical, but like, the ASCII number thing or something. Or the UTF-8 thing. I don't know which one. Above, we demonstrate that new list equals old list, brackets with a colon, creates a real copy of the old list. Although the syntax looks strange, it is a relative of something we already saw. In the string lesson, we introduced a way of extracting a substring. String, first to tail, returns the substring starting with the index first, ending with the index tail -1. We mentioned it can also apply to create sublists of lists. In addition, if you omit first, it takes the default value of 0. If you omit tail, it takes the default value of len, the length of the list string. So what really happens is that old list with just a colon is creating a new sublist but containing all of the same data as the original list, so it is a new copy. Method number 2, using copy.copy. There is a module called copy, which contains several methods related to copying. The simplest one is copy.copyL. When you call this on a list L, the function returns a real copy of L. Import copy, old list, first, second, third, new list equals copy.copy old list reverse, and then the same thing, you get two different lists, one in order and one in reverse order. Copy.copy function works for other kinds of objects, but we don't discuss them here. Method number 3, using the list constructor. The last way of making a real copy is using the list function. Ordinarily, list is used to convert data from other types to the list type. For example, list, the string hello, converts the string hello to a 5-element list, each element being 1 character. But if you try to convert something that's already a list into a list, it just makes a copy. Old list, first, second, third, new list, old list, creates a copy. And then we do the same thing. This is so interesting, guys. I didn't realize there were 3 different ways. I think I knew about this one. I think I knew about copy. I don't really believe that I understood this one and this one as alternatives. Lists as arguments. Notice that because of the way lists work, any function which accepts a list as an argument can actually change the contents of the list. You saw this already in the replace exercise. Meow, 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 meow. Oh yeah, I remember this one vaguely. Ha 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 ha. What number is output by the following program? Define func of list. List at 0, at index 0, is equal to list at index 0 plus list at index 1. List at index 1 is equal to list at index 1 plus list at index 0. Data equals 3, 4. Func data. Print data at index 0 times data at index 1. Okay. So, list at index 0. List at index 0 is element 3. Element 3 plus list at index 1, which is 4. Oh boy, oh brother, oh boy. Isn't that just... I think I'm confusing something. I think I'm getting confused already. Is it the value? Or is it the value? Or is it the value? Or is it list? It's an integer. I'm actually really confused. So 3 plus 4 is 7. So index 0 is 7. Ah, is that what it is? Is this 7? And then it calls this one at index 1, list at index 1, which is list at index 1, which is 4 plus 7, which is 11. 7, 11. Print data 0 times data 1. It's 77. We did it. Okay. Comparing lists using is when are two variables L1 and L2 equal? There are two different ways that we can interpret this question. They have the same identity. Are L1 and L2 pointing or referring to the exact same list object, or same values? Are the contents of list 1 equal to the contents of list 2? It turns out that in Python, the standard equality operator equals has same values meaning, as the following example shows. The meaning of equals equals. L1 is text 11. L2 is L1 in its entirety, a copy of L1. So L1 and L2 have the same values, and that should be true. This should be true. That prints true. To test for the same identity, Python has the is operator. We use the operator the same way as the equals equals the same way as equals equals, the syntax. Sorry, I was confused by the colon. List 1 is list 2. Returns true if the list refers to the same list, false if they refer to different lists, even if they have the same contents. So we have L equals text 11, L again equals L, so they both point to the same object. Print L again is L, it should give true. L copy equals a copy of L. Print L copy is equal to L again. They have the same value. L copy is L again. No, L again is L, but L copy is not L. Meow, 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 meow. Short answer exercise, true count. How many times does true show up in the output of this program? Draw a diagram to help keep track. Okay. Okay. A type of diagram. How about that? A type of diagram. List 1 is 911. List 3. Can I copy this? Are you guys gonna tell on me? I stole it. I copied it. I stole it. So this one is just some list. Then list 1. Okay, so list, the constructor, makes a new copy. New copy of list 1. List 2 is equal to list 1. So this references the same list as list 1. The same object. Let's put the same object. List 4 is list 3 with the, like, what is it called? The slice method. So this is actually, all right, the slicing, the constructor, and what was the other method? There was 3. You can make a, copy. So this one is a new copy. New copy of list 3. List 1 at index 0 is 4. Okay. So that's now that wait. List 1 at index 0 is 4, so now it's 4, 1, 1. And also that means, so because list 1 changes, anything that's a reference of list 1 also changes. List 1 and list 2 get updated. List 5 equals list 1. I'm in trouble. This should be, I'm actually in trouble. This is really confusing. References the same objects. List 1. Print. Print. List 1 is list 2. List 2 is list 3. List 3 is list 4. List 4 is list 5. Okay, let's see if that's true. Is list 1 the same identity, the same object as list 2? True. Is list 2 the same object as list 3? That's false. Is list 3 the same object as list 4? That's false. Did I put too many? I think I put too many. Wait, list 1 is list 2, list 2 is list 3, list 3 is list 4. List 4 is list 5. List 1 1, 2, 2, 3, 3, 4, 4, 5. Is list 4, which is a new copy of list 3, the same as list 5? False. And then, okay, does list 1, maybe I should write what they are. New copy. So this is 911. References the same object for 1, 1. Um, nine, 1, 1, 1. Do list 1 and list 2 have the same value? Oh, wait, I forgot to change it here. Well, it's changed here. List 1, list 2. True. Does list 2 have the same value as list 3? False. Does... I think I'm messing this up. Does list 3 have the same value as list 4? Yes, but they're not the same object, but they have the same value. They're both 911. And does list 4 have the same value as list 5? False. Ha ha ha, how many times does true show up? 1, 2, 3. I think the answer is 3. I think it's 3. I think it's 3. Come on, be 3. Yay! True, false, false, false. True, false, true, false. Okay. Yeah, we did it. You should not use is with strings or numbers because equals already correctly test equality, and the behavior of is hard to predict on strings and numbers. What is this? Wait. Why is tricky? What is this? Oh, this is like a whole other thing. You can test programs. Why is tricky for strings? Print foo is foo. Foo is foo. FO plus O. Both true due to string interning. Oh, I don't know that concept yet. E times 32 is EE times 36 is false. Long strings are not interned. A is foo. B is foo foo. A times 2 should be foo foo. A is equal to B is true, but A is B is false. Does not, doing times equals does not re-intern a string. Y, tricky for numbers. 1 plus 1 is 2 is true, but this behavior is only for small integers. 10 to the third is 1000 is false. 1.5 is 1.5. 1.5 is 0.5 times 3. The first one is true, the next one is false. Float nan. Float nan. Float nan is float nan. Both false. My brain hurts. X equals float nan. Print X is X. X equals X. True, false. One of few examples with is T, but equality is false. What the fuck? This one right here, sorry for cursing, this one right here broke my mind. How is it the same object, but it has different values? What the heck? What the heck? Also, is not the same. Compare ID. How are those? Wait, those are different too. The 0.00, 0.00. Oh gosh. Well. What's this? I'm scared. Uh-oh. It's loading. Uh-oh. I don't trust it. I close it. Hopefully I didn't just get a virus. Okay. I was supposed to do 2 hours. I don't feel like doing 2 hours. I quit today. Hi, kitties. You can hold down the power button for what? Power social baka. Ganyaning urayama unit. Many desko. Gamani Yovako. Oh, thank you. I don't hear that often. They're teaching you about the REPL, aren't they? You should open your terminal emulator and run just Python. I did that earlier. Bye. Run these as single commands. You talk. Oh, you wanted me to? You wanted me to run it? I could run it. I just didn't feel like it. But yeah. I didn't really feel like it. But I could do it. Fine. Oh, good work for today? Oh, thank you. Morning. Print. Meow is meow. Meow is me plus ow. Syntax warning. Is with string literal. Did you mean equals? No, I didn't. Okay, print E times 30 is E times 15. I want to see if this changes anything. Interesting. Does it depend on the length? Is 32 like the length? Oh, that's true. It said false. It said it's supposed to be false. Wait. 320 times 160. I think that's too big. Wait. Let's put it in here. True. Hey. Oh. Wait. Let's do 60. Wait, what's a good number? 45. Wait. 50. 25. I don't know. Maybe they updated something. I don't feel like doing this anymore. I'm done. Have a good day, everybody. Have a good day, everybody. Have a good day, Nick Lagulus. Thank you. I literally just read like an entire chapter of text about the equals, same identity versus same value. So I think I had enough. I run away now. Bye. Oh, let me out.